Okay, so your last video for today is going to be about extrema. So, extrema is a fancy word for maximum and minimums. Okay, so your maximum is kind of like a peak. I call it a peak of a mountain. So if I had a graph like this, the point up here would be my maximum. If I had a parabola like this, my minimum would be down here, and I tend to call it a valley. Okay, so you have a peak and a valley, your maximum and your minimum. Last year, you probably learned how to use your graphing calculator to find these. We are using Desmos, so it is 10 times easier to be able to do, and we'll look at that in a minute. Okay, now we have two types of extrema. You have what is called a relative, and I'm going to give you both because some people also call this local, depending on your textbook. I believe your textbook talks about local, but on your SATs and in different textbooks, I see different ones. Okay, so your relative and your local, and we call it extrema because we use it to have one word. Instead of saying local max and min, we say local extrema, and it satisfies both. Okay, so your relative or local is a max or a min, and these are abbreviated, maximum or minimum, that is not the highest or lowest point of your graph. Now, sometimes you might have a local, sometimes you won't. So, for example, if I was to have a little graph like this, neither one of these points would be the next example that I have. These would both be locals. This one would be your local max, because it is not the highest point of my graph. If I go off infinitely up to the top, my highest point is infinity. Here would be a local min, because if I go follow this graph all the way down, my lowest point would be negative infinity. Okay, sometimes you might have both a local and what's called a global. Now I'm going to put, it is also known as absolute. Now, again, depending on the textbook, depending on your SATs, I've seen it written both ways. So I need you to know both words. Now, your absolute or your global is the highest or lowest point of your graph. Now, you don't have to always have a global or an absolute. Just like local, you might have one, you might have none. If it was a linear graph, we don't have a max or a min. They just go off infinitely in both directions. Okay, so for example, if I draw an M here, you'll notice both these 2 points are my absolute or global max. Now, in this case, I have 2. Sometimes you might have 1, sometimes you might have none. In this case, we have 2. This point down here is going to be a local, because it is not the smallest minimum. Okay, and that's how those two would look. Now we're going to look at Desmos and how to find the exact points. All right, so this one is an example from your book, and I already put a Desmos picture here, so I'm going to go ahead, I'm going to bring up my Desmos. and I'm going to put this in. So I have, let's go to X, to the, I use the A to the B to get the power, 4. Then I need to hit to the side of it, so I'm out of that power. 7x, and then the squared is right at the top, plus 6x, and here is my graph. So for this, I am going to squeeze it down so we can see all of the points. And this is what is really nice about Desmos, is you can enlarge it, you could make it smaller, you can move it around so that way you can find the points. Now what you need to do is you hit each of these points. So I can hit here because I know that that is a minimum. I can hit here because that's a maximum. I can hit here and that's a minimum. If you remember how we found this on our graphing calculators last year, it's a lot more extra steps. Because we are using Desmos as of right now, as long as we are in the hybrid model, we are taking all tests electronically. So for the current future, all you need is Desmos to be able to pass these tests. Okay, so what we have now is going to be, now we write it down. So usually you'll have a spot that will ask and say, what is your absolute max? What is your absolute min? What is your local max? What is your local min? And then you go through. So a local max, we look back at our definitions. Those are the highest or lowest point of the graph. The absolute highest or lowest. So I do not have an absolute max because there is no highest point of the graph besides infinity, because this goes off infinitely on both sides. My absolute min, is there a bottom to my graph? Well, absolutely. Down here is the bottom of my graph. So my absolute min is negative 2.057, comma, negative 24.057. Okay. Local max, so do I have any type of peaks here? Absolutely. This would be my peak, and it is local because it is not the highest point, so I have 0.456, comma, 1.324. Okay, now local min, last but not least, this is a minimum, but it is not the bottom of my graph, therefore it is a local min, and that is 1.601. negative 1.766. And there is my last point. Just to also talk about, I know this video is only supposed to be a local extrema, but I don't want to take for granted. You guys can also find your X and Y intercepts by clicking here. This is where you cross the X-axis, so those are your zeros or your X-intercepts. And 0, 0 is not only an X-intercept, but it is also a Y-intercept as well. All right, that is it for your videos. You have one last slide to be finishing in Nearpod, and I will answer any questions tomorrow.